Okay. I've already been introduced, so I'm not going to do that again. What we're going to do is we're going to build an agent which interacts with database to help you fill your timesheets and just nudge you into the direction that you've not populated a timesheet this week. Please do it. But before we get into doing that, why do we want to build this? Have you ever been in this situation where someone pinged you that, oh, you haven't populated your timesheet this week? Maybe on a Friday evening at 4:30. Yes, quite a few people have had this. And every engineer hates populating their timesheets. I hope that's the case, because I do. So I just wanted to look at ways if we can just not go into the system, type down my timesheet for that entire week, and be done with it. So hence we are here. We will build a timesheet agent, and I hope every one of you can build something out with the code that I provide and learn how agents work along the way. The agenda is I'll introduce you to AI agents, because they're not chatbots, to be honest. And in today's session, you'll see a chat interface, so you'd think that it's a chatbot, but it's not. Agents can actually act on your behalf rather than just chat to you and find information for you. I'll introduce to the workshop of the database design, the schema stuff, and how the agents interact with the tools. And finally, we'll go on to the hands-on workshop. So I'll keep the slides short, very short, so that you can actually perform the workshop yourself. What are the components for an AI agent? It needs an LLM, right? Everyone's talking about Gemini, ChatGPT, all of that. So it needs a model. It needs an LLM behind it to power the reasoning, the logic, the communication with the user. It also needs instructions, right? What is it supposed to do? So if you're building an agent for timesheets, you need to provide instruction that this is my timesheet database, it has these schema, it needs these tools and whatnot. So it needs instructions on following your workflow, that look at this assignment first, is this project actually assigned to this employee and whatnot. So you need to do all of that. So that's the instruction bit. Then we have tools. So tools can be anything. It could be Google search. So on a lot of Google models that you see, you get Google search out of the box. But technically, that's a tool for you. You get RAG engines as tools now. You can build your own custom tools. That's what we're going to do today. We are going to build our own tools that interact with a timesheet database, or technically, you could build tools to interact with any database. There are quite a few input and output tools. You could have a tool that streams your data somewhere. It caches, it does vector storage for your input, all of that. You can do outputs on a very specific data format. And finally, there are sub-agents. So in the agentic era, you might have heard of multi-agent systems, multi-agent workflows. So an agent can have a set of sub-agents that can do very specialized tasks. So coming to the sub-agent side of the things, there are workflows, right? If you have 5 agents, then they can do something in a very specific manner. So the simplest one is a single model architecture. What it does is you ask it something, it provides you back something. It has access to tools and whatnot, but that's all it does. The next type of workflows that are very common is sequential models. So a lot of scenarios, and in this case as well today, you'll see that when you instruct the agent, you ask it to do some very specific sequential tasks. So rather than typing out the instructions, you could split it out into multiple agents that always perform the tasks in a sequence. There are parallel models where you can make your models, your agents have access to multiple agents which do something in parallel. And then you have an aggregator agent which would pick out the outputs from your parallel steps and give you a result. So for example, if you're deploying something, one agent can deploy, the other one keeps polling for it, the third agent can just look at the logs and revert back in real time and whatnot. So you could have multiple models that do things in parallel. And the final one is hierarchical routing. So in the same case where you have three models, three agents, and there's a supervisor agent that would decide which agent goes next. Probably one agent specializes in reading the timesheet, for example. The other agent specializes in writing to the timesheet. The third one is just a validator. So probably your supervisor model, the router model, would identify the intent of the user and delegate the task to the agent, which is the closest matching to what the intent is. So for example, I just want to look at my timesheet, so I'll go and trigger the timesheet reading agent, for example. Something like that. So what we're going to build today is just from these two slides, a combination of them. So we're going to build a single model architecture. I know, very simple, right? Just put everything into a prompt, give it tools, and it does the job. So we're going to make it simple so that for beginners it's easy as well to get your hands on. We'll use Gemini, of course, give it some instructions, and then make our custom Python tools. So the Python tools that we're going to build are on SQLite. So the reason I chose SQLite is it's Python native. Everyone has access to it, so I don't need to set up or instantiate a database for now. Everyone has the access to it. Very lightweight as well. So one tool that we'll build is get summary. So it's just, did this employee work in the past week? That's a summary, right? And not just that, but also what project did this employee work on? How many hours did the employee work on that? Getting assignment, what project is this employee assigned to? And then insertion as well. So there's a tool that would insert those information that you get from the agent and push it to a timesheet database so that you don't have to. Database schema time. I've built a very simple schema. How many of you can actually understand what's happening here with this schema? Oh, that's a lot of people. I like that. Okay, so for the people who are not a lot involved with databases, I have an assignment. Let's start with an employee table. So there's an employee table, which has an employee ID, a unique key with some additional information. I don't care about that for now. I have a projects table, primary key with a project ID and a project name. Don't care about additional information for now. I tried to make it simple. They're both linked with an assignment database, assignment table, which is an assignment ID is linked to a project and an employee. So an employee can be assigned to a project for a given start and end date. And then finally the timesheet, which is the timesheet ID for this project. This employee worked for X amount of hours. Very simple, very basic. I don't think it's going to be a problem for setting this up, but if you have questions during the workshop, let me know. And as I promised, a very short slide, and we'll get into the workshop. Hopefully you are as happy as this fox is. But before we jump into that, a final reminder, if you haven't redeemed your credits, here's your chance. I'll give it 5 seconds. If in the meantime, you can just scan this QR code and get your GCP project up and running. The next one is clone this repo. There's a command as well, so if you're on your laptop, you can just type it in or just scan this QR code, which will take you to the repo that I've created. And this contains the agent, the database design, the schema, the insertions, and all of that. And I will, of course, walk you through it. Actually, let's go to the workshop itself. So this is the repo that you'll all be seeing. Make sure that you clone this repo. And there, yes, link. Okay. I'll give it a couple of more seconds and then I will move on to the repo again. Okay. So a very lightweight repo, so it's easy to understand. There is a folder called Timesheet agent that has your tools, the database itself, and the agent. I'll talk about that soon. There's a requirements file, there is a README, but the most important one for everyone here is the workshop.md. What this tells you is what commands do you need to just follow the workshop, get your agent up and running, and then we'll go into implementing stuff on there. While you guys clone, I will show you what you need to do. Once you're on your GCP project, click on the Cloud Shell on the top right. That gives you access to a lightweight VS Code kind of environment where you can actually code, you can look at your files and run your code.
Can you go back
To
the URL?
Yep. Are we done? Awesome. I'll get back here, and in that time my oops. So you'd get something like this to authorize your Cloud Shell. Cloud Shell is pretty much like a terminal on your VS Code machine, and what it gives it all of the Google Cloud SDK. You have SQLite installed, you have Python installed, so you don't need to think about the versioning conflicts and whatnot. And if you have any questions, please raise your hand. We have a few people to help you out, and if not, I'm here, just come up on the stage. I won't be able to come there. But if you have questions, please raise your hands. Once you go in here, just cd into timesheet agent workshop. It's all on the repo itself. You can follow all the steps there, but I'm just going to give you a quick one on what it looks like. Oops. Okay, so the server is up and running, so you just click on this and follow the URL, and that would take you to your agent. Click timesheet agent on the top left, and here you go. If you just ask hi, it's fine. It would do something, and you can also track what tools have been called to get you an answer. So you have all of the traceability. So it looked at today's date, it did a date math where it said the entire week, went back, get assignments, it got the summary, and it looks like your timesheet for the period 12 to 18th is up to date. Good job. All the finance people in your org would be happy looking at this. But you wouldn't see this because for you, it's a fresh start. So your timesheets are not populated, and it's your job to fill it out with the agent today. How many people have been able to clone the repo and install the dependencies at least? Nice. We have one. If there are questions, please raise your hands. Yeah, what's that?
So just one Python file to do the whole app, agent
That's just the agent py. Then there's a couple of Python files that we import into the agent. And okay, that's a very good question, and I'll actually walk you through that.
walk through the agent.
Fantastic question. Let's do that.
Yeah.
Okay. So how does an agent look like in this case? Let's go into the agent.py file. What is this? Okay, nice. So in here, if you see, I've been importing a few tools from my toolset, and the fun part about it is all of the tools are just written in Python. So there's no AI magic in here. It's as simple as a tool that you can imagine. It just sits there in Python and your agent can access it. So the entire purpose for this workshop is to offload the smartness into your tools, because the agent can just call the tools and your tools would do the action. And I know a lot of people here are not AI specialists or AI engineers, but have a background in software engineering. And I just wanted to make sure that you understand that most of the AI engineering work that you'd be doing relies more on building the tools rather than building the agents themselves or LLMs themselves, because they're already there. You're not going to reinvent the wheel, but you can create new tools that make your agents more powerful. And as you saw in the previous one, how did Jules create a pull request? It had a tool to create a pull request. How did AI Studio look at your code, parse it, and then write something up? It had a tool for that. So it was still Gemini 1.5 or 2, I don't know which one because they didn't tell us, but Gemini 2.5 or 2 or whatever it is, it's quite generalized, right? So it doesn't know the context. So there are always tools that are going to help it. In here, we go into the agent. So that's the agent definition. You give it a description. You say, oh, you are an agent to interact with the timesheet database. That's it. And there is a huge, huge, huge instruction set. And that instruction is just plain text. It tells you apply constraints. So it says only apply it on weekdays. Daily limit is 7.6 hours unless it's approved. I said our increments can only be a multiple of 1.9. So I don't want people adding 0.1 hour to something rather than just having specific bins of entries. I'm saying when your tasks are complete, give me the output in a very specific format. So all the instructions it's here. And finally, I'm telling it that these are the tools that you have access to. Did someone notice? I had these two tools, get today's date and get math. Why do we need that? Yes.
Like, for today's date, you're like the model only thinks that the day is the day that it was last.
Yeah, exactly. That's the exact answer. And as Gishan mentioned on the previous one, is models have a cutoff date for training. So they would think that this interaction is happening back in the past. So they don't have information about what today is. So you need to give that information as a supplement information. So now when you say something about today, tomorrow, yesterday, something, it would first call what's today's date and then do a math of tomorrow is today plus 1. So you need to do all of these tool definitions for an agent. And as I mentioned, unless you give it the right tools, your agents do nothing. So if I just remove these tools, even with this huge instruction set, my agent would do nothing. It would just say, I don't know what to do. So the entire purpose on this one is just to offload that heavy lifting onto tools. And looking at the tools, I'll go with the easy one first. That's the tool that I wrote for getting today's date. It's just date time.today. That's all it does. Date math, add days, subtract days, whatever it is. Database tools are a little bit fun. So let's say I have a tool called get assignment metadata for the employee. It needs these inputs and the output would be a dictionary of strings. But then I need to tell the agent on what this tool actually does. So I need to give it some more information, context, that when you have something around this intent where the user wants to see their assignments, this is the tool because it has the description that says, okay, assignment. If I change this description here on the tool and say that this tool draws an image, then it would never go to this tool, right? Because it doesn't know that this is the right tool for my intent. So the doc string that you see here are one of the most important aspects of creating your Python tools. And now if you look at the tools, they're just plain pure Python software. Like you might have created something like this. It's just running a query behind the scene that is For this employee and this start date and this end date, get me the assignments. So if you look at that entire code, and now that you have cloned your repo, you'll be able to see all the tools. All the tools are just plain Python scripts. Some of the people are laughing, but that's the hardest part of AI engineering, because you're not going to train your models every day. You're just having a model, but these tools are the backbone of your AI agent that can do the heavy lifting. Timesheet summary, it just runs a query again. Now, some people would say, why not use a database MCP server that can write these queries as well? The LLM models are quite smart at writing new queries as well. But sometimes you just don't want to give that control over to LLM, because it's a very sensitive thing. You don't want random entries going in. You need to create your own custom tools that do very specific things. And possibly, because this is a very simple case, you think that it's a query. What if your company exposes APIs rather than giving you access to the database, right? Because API is more structured. You could just change this bit here and call the API with the inputs that you got. As simple as that. So it's not about writing or creating new LLMs, but it's more about creating tools that do the work. And all of that gets tied together when you run this tool, and then you can see what tools get executed. If you look at, where is it? If you look at this one, when I asked it, let me zoom in a bit. So when I invoked something, it went agent ran, it calls the LLM first. LLM then calls a tool, which is get today's date. Then it goes back to the LLM, execute date math, and it gives you a full trace of what tools were called to achieve the final output and how long it took. So it gives you a full trace of what's happening behind the scene. And I see a lot of people going in there, trying it out, and I would let you guys enjoy it for a minute. Let me know if there is any questions.
Hello. So thanks for walking through this. A quick disclaimer, I'm terrible at coding. My background is in aviation engineering, so I'm here to just learn some different aspects. This guide that you've shown, is it assuming that you're like a software engineer at a large company and you have direct access to the databases or the APIs? So then if, for example, for me, I'm not that person, could this approach be kind of tailored where you're telling the AI to go to a GUI and say, read this part of the screen, this corresponds to this field, and then almost interact with the GUI as an individual user?
Yes, it can. But then you'd have to write that tool, or you can use a few tools out there. But then writing that tool, again, is a software engineering exercise. So it's more tailored towards that. Fun bit is all the tools that you see here have been in some way, shape, or form written by Gemini. I vibe coded my way here, so you can do the same. But the point is, it would make a lot of mistakes along the way. So you need to have that eye on finding that, oh, this is wrong.
Thanks.
Okay, there's 3 people who have completed this bit, which is amazing. We still have half an hour and 3 people done. Nice. Yep.
How do you think, what am I accomplishing with it? Like, it will remind me, or like it will just create, so like...
Okay, yep. So that's a good question. At this point, it's not going to remind you because we are just creating it locally. But with the connectors that you have in mind, you could have a scheduler, let's say at 4 p.m. Friday, it triggers the agent. The agent looks at the assignment for every employee. The tool's already there.
And is it only going to be creating where it will create the timesheet every day? Like I will just, for example, I'm using such as SAP timesheeting. So
Yep. SAP has APIs, yep.
So do I need to create a connection with SAP in this particular code?
Yep. So this is not going to fix your problems in a week. Where at your workplace, you need a lot of approvals. You need authentication tokens to be able to communicate with your SAP API, for instance. Yes, there are APIs that you can use, but again, authentication would be the biggest bit. Eventually, if this thing works out, what you can do is deploy it on a server, which has authentication token. And you can only interact with the agent. That agent can look at everything, send you a message or an email. If you've already filled your timesheet, all good, but most of the people don't. So you'll get an email saying, oh, I don't like email, but let's go for it. So you'll get something like, where are we? Sorry. So you'll get something like this. Most of the people who are running it would not get this, but you'd get that, oh, for the last week, you haven't populated your timesheet, but you're assigned to project A for these 2 days, project B for these 3 days. Did you work? If you say yes, it would just go on and do everything for you.
So like, have you configured a connector over here? Like where is it doing?
Oh, currently the database just sits on your machine so that everyone, as I said, it's a SQL-like database that sits locally.
Understood. I'm not, like, it's impressive. I'm just saying, like, I was just thinking.
No, of course, that makes a lot of sense. And that's what we are actually planning on doing as well. We have a Slack agent already, it just pings people, but currently it does not have all of these information. It would just ping the user to say, oh, please fill your timesheet, it's not complete. Rather just have a better message with all of the agentic stuff saying, oh, did you work on these projects last week? If yes, that's it. The user has to do nothing else, as you see here, right? Yes.
Just getting an error. Like, I wanted to work, but then I did something else.
What was the error? Just bring it up. Just come up, that's fine. Sorry, but yeah.
So this is the error message. Like I ran the ADK and ADK web, and now it's saying that application shut.
Oh, so this is saying that it's already there. So I guess you tried to run it twice.
I think so.
Yeah. So I forgot the exact command. Give me a second. I have it on my phone.
These things, like,
So it would just kill all of your app that run on 8000. Now it should be fine.
And like when I click on the link itself, it basically either gives me the, if you click on it,
Oops.
click on it, and then it basically gives me like select an agent. So it gives me
A timesheet agent, yeah. Just click on there, and there you go.
So if in my environment variable, like
Yep.
I have written my Google project in inverted commas because there was a space in between them. Could that be?
Oh, that's not your project code. So your project ID is this.
Oh yes. Okay, my bad.
So you just copy this.
And then yeah, okay, that's it. I guess that's the problem.
Oops.
That's alright.
Set that. And now
I think there will be a decay web, I guess, somewhere.
I think if you just refresh it, or is it an instant? Yep, you'll have to just close this. How did we close that?
It's taking its time, I guess, this time.
Yep, the same command. Where did we run it before?
In here.
Oh, right, it's
It's in the that's like you have yeah. So if you click on the terminal and this, it will reconnect itself, I guess.
okay, that's okay.
This, yeah, I'll see the command afterwards.
Yep, yeah, it's just killing anything that's on 8000 port.
8000 port, okay.
Yeah.
Oh, okay. Good. Click on that.
Oh, you have both of them.
I have a collection. Again, no root agent found.
We might not have executed that from the right path. Sorry, I've been a bit hasty.
No. Like, I've been a mess, man. Like I need to curate my.
Okay, so you don't need to be here. You need to go into the workshop. That's the root, right?
And
So
then
that's where you have everything. And now if you do
ADK. What does ADK stand for?
Agent Development Kit,
And then okay. And the shift. I think yeah. That's it.
there you go. And now, hopefully there are no errors. Oh my god.
403 permission.
Oh, you need to enable the APIs. It's a new project, right?
Yeah.
Oh,
Yes.
I should have done that. If anyone gets a permission denied on Vertex AI, just go onto your Google Cloud project. Yep. Okay. So let's go back here. So before you turn on your project, you just need to make this true. And because this is a call to Vertex AI, you need to give a project and your location, which is already set for you in here. If you go to timesheet agents, env.local, you already have this set as true, US Central 1, and this is where your timesheet lives. All you need to do is copy this into a .env file. If you look at, again, let's go back to the workshop steps. So once you populate these environment variables, you just need to create a .env file based on env.local. So now it would not ask you for an API key. It would go to Vertex AI, but there would be a problem again. So you just need to go to Vertex AI, just open this. So just search for Vertex AI, whatever comes up. For me, it's not a problem, but for you, it would just say enable the API. Enable it, and you're good to go. Just Vertex AI, not search, just Vertex AI. Go to Vertex AI. The first one that you get here, if you see this icon, it's Vertex AI. That's it. Go in here. It would ask you to enable the API. So you need to copy your .env.local file into a .env file before you run it. Yep, just enable API when you get the pop-up.
And then I have to do the ADK web again, or
It's fine. You don't need to run ADK web again. You just need to refresh and it should be fine. For the people who have already finished, I have a challenge because you already finished it, right? What if, just think of a way to change this single model architecture into a sequential or probably hierarchical routing. Look up ADK docs. Try to just switch this into a sequential model or hierarchical model based on what you want to do. You already have the tools. So you just need to create 3 more agents and create a workflow. It's only for people who have already completed the simple task, and now we go on to the harder challenge. Yes.
I do have a question. I think you tried to explain, but I couldn't fully grasp it. So I don't have a background in IT.
Uh-huh.
So can you explain it again? How does the agent will know which tool to use? Is it inside the Python, or is it?
Correct. So the question is, how does an agent know what tool to call,
Yes.
right? Because it has access to more than 5, right? So if you look at this, the agent has 1, 2, 3, 4, 5, 6, I think. How does it know where to go? So when we import these tools, if you look at the tool definitions themselves, so let's go to the simpler one. It's easy for everyone to follow. There is a docstring on each function that we define. Some are just as simple as that, but some are a bit more complex. Then you need to give a longer docstring, which is what does this tool exactly do? What arguments does it expect? And what would the tool return? So when the agent loads these tools into its own tool set, it now has a reference of what tool does what.
So this is like a comments kind of thing. And then
Yes, it is kind of a comment, yeah.
yeah.
So it's like you, right? If you know that this guy is good at doing something, you would go to this person and say, okay, I need help with this. Or this person is good at something, you go to this person. But to know that, you need to have that context, and that this is exactly that context for each tool.
Okay, yeah, makes sense. Thank you.
Yes. Can we get a mic there? Second row.
What's the major difference between the ADK and the LangChain and some similar frameworks?
They're all the same. They do the same thing. It's just different framework, right? So it's like any other. So are you full stack?
LangChain.
You use LangChain? Yeah, it's exactly like that, but it just have a different syntax. And this one, ADK was released by Google. Again, open source. So it's very similar to that. LangChain has more of a state graph method if you create a new agent.
Yeah.
In here, it's a bit more high level where you just define what tools does it have access to. So it's a bit more abstracted, let's say.
Okay, thank you.
Yes. Memory. So what specific, so are you talking about the session memory, or are you just talking about a memory graph that it creates on the back end based on your?
Yeah, because I usually use LangGraph.
Yep.
So they have like the state graph you're talking, it has inbuilt memory and all of that. So
Yep.
ADK.
It has the same inbuilt memory. So you could create as a session,
Yeah.
and it would keep that as a session object on the back end.
Okay.
Depending on where you deploy it, it would also keep the track of your session states. So now if you have 5 users, they would all have different session states.
Yeah. So does ADK recommend anyone? Like, because I use Redis to store all the memory. Does ADK have, like, or Google has something they recommend users or something?
So I don't know if there's any recommendations on that. I think Google has a service called Agent Engine, which has memory set up already. So you don't need to worry about setting up any database or something. It just takes care of you. classic Google, right? It just abstracts everything for you.
Click a button and it's done.
Yeah. So it's exactly the same. So if you push it onto Agent Engine, it takes care of the memory as well. But you, of course, need to programmatically set it up on your agent, but then
Okay. Yeah. Cool. Thank you.
you don't need to worry about the infrastructure. That's all I meant.
Yeah, of course. Yeah. Thank you.
Hello, just a question about hierarchical agent architecture.
Yep.
How do you generally approach how many agents you put into completing the task? Is it the same as an org, or do you go smaller, or?
I haven't hit the limits myself, but I've read a lot. And what I've found out is, as a general rule of thumb, one agent should not have more than 5 tools.
5. Okay.
Now, what you could do is create, like let's assume you have 20 tools that do different things. Then one agent would specialize on only doing 5 tasks. The agent number 2 specializes on doing something, only 5 tasks, assuming.
Okay.
So you can split them into 4 agents now, right? 5 into 4, 20.
Yeah.
And there would be a supervisor agent which has these agents as tools.
Okay.
So now it becomes a hierarchy where I would only call a specific agent which can perform something, comes back to me as a supervisor agent. I can call the next tool again. So there's no limit that you can only call a tool once.
Yeah.
Oh, sorry, agent in this example. So usually recommended one agent, 5 tools, not more than that, unless you have a very solid case for that, but 5-ish. And one agent can then have 5 sub-agents which access more tools.
Just a quick follow-up. Okay, thanks. It's good to have a kind of magic number in mind.
It's not a magic number. It's just some people who have heuristically identified that. It's a decent recommendation, I'd say, because there's no consensus. It's just people writing about it, and I've read it.
Magic in my mind, at least. I guess how do I observe like degradation in performance? Say, how do I know an agent is doing too much? Is it just that the overall workflow is not working out, or?
That's an amazing question, because that's a question that so I work in consulting. I get these questions a lot from my clients. And no one is actually doing the evaluations bit as they should. What you should technically do is add evaluations on all of your agents. So let's assume, this is very, very complex, by the way, so people who are new to it, don't get scared. You'll get there. So if you go in here, you can see what agent has been invoked, right? When?
Yep.
So that's the first thing. You can log this into a database, saying, okay, for this specific invocation ID,
yep,
I called tool 1, 2, 3 in whatever sequence I did.
Yep.
Log it. Log everything there onto a database.
Okay.
And then there's a test set which would run against it and saying, okay, for this specific query, my agent needs to call tool 1, 2, and 3 in the sequence. So that's called a trajectory trajectory test or something like that. So there are 5 different trajectory metrics that Google has released.
Trajectory tests. Okay.
Yeah. So it's first one is it calling the right tools? The second one is it calling in order? Then there's a test for input outputs. So it's like a unit test, right?
Yep.
So you would run unit tests on your tools. So let's say I have database tools. Again, this is a very classic software engineering thing to do. Is in here I've just added a main which I can run this, right? So I could just assign a few unit tests to this Python file now.
Yeah.
Because it's still an independent Python code which can also work with agents. So now I could run unit tests on my tools.
Oh, I see. Okay.
So it's a twofold. So one, you test your tools. The second one is your agent calling the tools in order, in sequence, or in whatever format you need to call.
Okay, so it's kind of like, from the agent perspective, it's kind of like expected workflow. That makes sense. No, okay, thanks.
But everyone talks about it, no one does it. Honest answer. What's that?
Do you write? I'll follow your LinkedIn. If it comes to me, you find the answer.
I do. Not as much as I'd like, but yes, I do.
Hey Yash,
Oh, yes.
just following up on that, if we have a lot of agents in a hierarchical structure, is there a preference for the model? Which model do we use? Do we use Dev 2.0 Flash? Which model is better at tool calling?
No, so there's no recommendation on what model to use as a silver bullet. There are some models that are very, very specialized in doing some things. Usually, people prefer Claude models, Opus or something like that if you're creating a tool that codes. So it's 100% up to your use case on what model you need to use. Tool calling is not usually a concern anymore because almost all models support tool calling, and tool calling has become a fairly straightforward thing these days. And all of those tools that we're creating here are still just for your understanding. Now there's MCP servers now. So, so deciding your model is more about your use case. So if you need code, then usually, as I said, Claude. Gemini 2.5 Pro is really good as code as well. Way cheaper than Claude. So again, all of those factors would come into play when you decide which model to use. But there's no hard silver bullet that would say, okay, use this one. And sometimes in organization, it's also about approvals, right? Some organizations want to use ChatGPT, they would just go with that, and you always use that. Some organizations align with Google, so they would go with Gemini. Usually it's something, so those factors play more of a role than tools. There's a mic.
Yeah, I mean, that's interesting. I just want to understand maybe your personal way of doing this. Is if you start with one of the more expensive models, let's say, per token cost being higher, to sort of proof test a way of working, how would you go and sort of maybe try to find, in some of these steps, for example, the sequential model, that maybe I can use one of the low-cost models in between there and still get decent results. And how would you sort of verify that? Because, I mean, it is not deterministic like you said.
Correct.
Right? So,
yes. So testing is quite new. Not a lot of people do it, as I mentioned. But there are fairly few testing terminologies that people are starting to adopt within the agent environment, let's say. Should I say environment? But anyway, that's fine. In the agent space. So let's say you started with a large model, Gemini 2.5 Pro example, or Opus. And you realized, okay, it works, but it's super expensive now. So usually you could frame a test set that, let's assume Opus, when I asked, because now you can log all of that your agent does, your agent called this tool with this input, this output, this input, this output, right? You can log everything. So now you would, for example, you're competing with Opus. And it's doing not super complex task, assuming. You log all of that. That becomes your test set. Now, let's pick up a cheaper model, Gemini 2 Flash, which is not super old, not the latest, cheap, works fine. You run it against the same test set and compare, is it calling the same tools in the same order? One, because your tools are already unit tested, you don't need to worry about the tools. You just want to worry about if the tools are being called correctly because your agent is doing that. And finally, just a summarization. So now you can do, is your agent summarizing similarly or even close to what Opus was doing? So now you can do similarity checks between outputs. So it's always like if you start with the expensive model, that's a good thing because you have a baseline, a test set for yourself. You can, of course, filter that test set out and then run it with a cheaper model and see does it perform the same? Because sometimes the tasks are not that complex. You're not, in most agents that I've seen, they don't do a lot of thinking. It's more about tool calling over time. Unless you're, so they work well with chats where it's very general purpose. You want to do some coding and stuff like that. That's when you decide, like, go for the heaviest hitter. Yeah. Sorry, I can't hear you. Mic again.
I thought you could hear me. No, at the end of the day, this would also be like standard unit testing that we've been doing for decades.
Yeah, 100%.
So in the sense, you'd, of course, have to do the similarity sort of test at the end, which would be another LLM maybe.
Yeah, you could do that, yes. There's a lot of discussions around how do you do similarity test, because sometimes models are biased. They like their own answers. So you could have an ensemble of models judging each other. There's quite a few ways. It's on your budget, how much do you want to spend on there. And again, as I mentioned, tools are pretty much your Python scripts or JavaScript scripts. Doesn't matter. But if you add unit tests, then you're sure that your tools are doing what they're supposed to do. Now it's on your agent just to call them with the right parameters. Yes?
Create the workflow, you need to enable the workflow API?
No. So these workflows are ADK workflows. So if you search ADK workflows on Google, you'll find out the documentation that what kinds of workflows you can. And it's pretty much these four. Maybe the names might be a little different. I've just simplified that. Yes? Mike here, please.
Like, I see all the workflows, right? So are these, because now Google has released their A2A protocol. So obviously if you have a multi-agent setup, does ADK does it underneath, or we still have to explicitly use that protocol? Because I know both.
That's a good question, and I don't know the answer to it.
Okay.
I imagine they would have ADK, like ADK would have A2A support by default, I assume,
Yeah.
because it's Google. I don't know.
Yeah, that's what I was assuming, but I just wanted to confirm as well. Okay.
I'll have to look it up.
Yeah, cool. Thanks.
Oh, it's time. Hopefully, everyone was able to, or at least most of you were able to wrap up your code. You were able to at least interact with your timesheet agent a little bit. There's quite a few things that you can do on top of it with automating it and just integrating with Slack, Microsoft Teams, or whatnot. Hopefully now you're as happy as this fox with this timesheet agent messaging you every day. And finally, a reward for finishing your workshop is the badge. If you all scan this, you would get a badge for build with AI25, and that's where it would be attached to your Google developer profile. So I'll keep this open for a few minutes so that people can claim their badges. And I think there was one last question there. And that's the last question. You can have a chat with me after, because we're out of time.
Thanks, Yash. This is a very comprehensive demo that you've given. My question is basically, in addition to the last one, which is the testing of basically this test strategy that needs to be followed to see if the agent tool combination is working perfectly or not. So I believe that there would be a limitation to the number of agents and the combination of the number of tools that can be combined along with the agents. There must be a limitation on top of that. And is there a situation or a use case where if a single agent is handling a lot of tools and it starts to hallucinate in that situation, because nowadays the agents or underneath the hood, the LLM is coming up with the reasoning capabilities. So are there any situations there where the agent starts to hallucinate because there is a limitation or a constraint on the number of agents or the tools can be called?
I personally haven't ran into those limitations, so I can't say out of my experience, but quoting a few articles that I've read, as I mentioned, that usually the magic number is 5. An agent should have approximately 5 tools. You can go over, that's fine if you have a very specific scenario, but 1 agent, 5 tools. And then if you follow the same approach, if you go into the hierarchy, then 1 agent can have 5 sub-agents, and 5 sub-agents have 5 tools, so you have 25 tools anyway. It's not, it's something that you need to heuristically test for your application because there's no silver bullet. I'm just saying that this is something that I've read on a couple of articles. That's not the silver bullet. It could 100% be wrong. Your agent could work fine with 20 tools. In this one, I said at 7, I guess it works fine. So it usually depends on the complexity of what you're trying to achieve as well sometimes. So it's a heuristic. There's no silver bullet. You just test as you go on this one. Okay, that was it for today. And I'll be around if you have any questions. Reach out to me. And thank you all.